Hello guys, welcome to my channel. Yes, the quality is terrible, and this is essentially the start of my YouTube channel, which I'm pretty excited for. So a couple things you guys should have to know about me before we start this channel is, number one, I'm addicted to coffee and carrots. It's kind of weird, but yeah, this channel is essentially just gonna go over a bunch of stuff that I enjoy. I love chemistry, I love math. My hair doesn't usually look like this, but yeah, and let's dive into it. I'm gonna start with a simple algebra video, and I'm gonna teach a little bit about math, about chemistry, about physics, about maybe computer science even, and biology for sure. And hopefully you guys enjoy this video. Hopefully you subscribe. This means a lot to me. This is the start of my journey, and I was inspired by Khan Academy, honestly. Yeah, pretty random, but the point is that I just want to go out there and help people, and I don't know, do it in a way that I enjoy. I'll go more into my background, but without further ado, let's get started into this quick algebra video. Okay, so in this video, I just want to go over a little bit of factorization and cancellation. Nothing too fancy. So we're going to start a little bit of overview over polynomials. So what are polynomials? Well, it's exactly that thing you see at the top. Doesn't really matter. But in this case, you got a quadratic above. So that means it's x is to the power of 2. And what we're going to want to do is factor it. So how do you factor it? Well, you can break it down into three things. So you got the x in the front, which has a 1 as a coefficient, the number in front of the x, a -6, and then a -7 in the end. So we're going to think what times what gives you the -7 in the end, yet when added gives you the -6 in the middle. And in this case, we can think, you can stop the video and think a little bit, but I'm going to go right ahead and realize that the answer to this is going to be -7 for B, and for 1 for the A. Now, it doesn't really matter the order, because what we got to do is follow this pattern of x, or the space, in this case -7, and then the next one multiplied by the x, in this case a +1, right? So we're going to do this x minus 7 times x plus 1. Now, in the bottom, the denominator, you know that I did a factoring out, so I just took out the 2, and I realized that if you put it back in, it's going to be the exact same answer. Why did I do that? Because if you realize, those two cancel out, so we get this x minus 7 in the bottom and in the top. So that's just factoring out. It's a really powerful thing, and as you go into your math journey, you're going to realize that that's essentially all of math, well, a big part of it at least. And that's our final answer. Yeah, little smiley face. Now, for the next problem, we're dealing again with polynomials, but you note that the coefficient in the front is not 1. So whenever this happens, even if it's a -1, well, the -1 you can kind of play around with by factoring out, but in this case, you're going to have to do factoring by grouping. That's at least how I like to deal with it. Many other people do different things, but all you got to do is get that coefficient in the front and multiply it by the c, the last thing, the -6 there, and we get -24. Now we think, what times what gives you -24? Yet when added, gives you the middle, the b. In this case is -5. And honestly, if you stop and think about it, that should be -8 and a 5, because when you add those, you get exactly that -5. Yeah, when you multiply them, you get that. So now what we're going to do is break that -5 into this 2. So -8x plus 3x, which again gives you the -5. Why do we do this? Because then we can do this sexy thing here, which is essentially putting it back into construction, and we put back that -6 and that 4x squared on both sides. And we note that you can factor out again. Now, note, what do these two things have in common? Well, in the left side, we got that 2x in both sides. So we factor out, sorry, that 4x on that both sides. So if we factor out that 4x here, you're going to actually end up having that x minus 2 here. And if you factor out 3, you get that x minus 2. So what do we note is that both terms on the left and the right, by the way, a term is that whole thing was it's essentially broken down by a plus or a minus in the middle. They both have that x minus 2, so we factor out again, as I told you, keeps happening. You factor out that x minus 2 out, and you get this 4x plus 3, which is a leftover after we factor out the x minus 2. Beautiful. So that's our denominator. Now our numerator, we're going to do the exact same thing we did before, where what times what gives us that -6, and when added gives you that 1. And in this scenario, it's going to be, let me think, it's going to be a is equal to -3, and for 3, and for our b, it's going to be -2. Yeah, so that looks right. So you're going to x minus 2 and x plus 3. And why do we do that? Well, now you can just cancel them out, and the final answer is that right there. Beautiful. Okay, now the next question. Okay, so now what we're going to be introduced into here is called difference of squares. So you note that there's a perfect square up here. You got the 49, which you know by elementary math that that's 7 times 7. So this difference of squares is actually as simple as thinking a squared minus b squared is actually just going to be equal to a plus b times a minus b, or a minus b times a plus b. You note that this doesn't really matter, the order doesn't matter. The point is that here what we're going to get is that 49 minus x squared is the same as saying x minus, sorry, 7 minus x times 7 plus x. And that's beautiful because that allows us to get this numerator simplified. And the bottom, well, we just got to think again, a times b gives you 14, yet a plus b equals negative 9. What would that be? Well, it's going to be negative 7 and negative 2, right? If you add them, you get that 14. If you, sorry, that negative 9, and if you multiply them, that 14. So now our top and bottom, again, following that same pattern of the top is just a difference of squares, and the bottom is just the x minus the 2 and the x minus the 7. But we note that we can't quite cancel it just yet. So we're getting there. You want to factor out a negative, right? Because if you think about it, if we remove that negative from the bottom or the top, we're going to change the order, right? So x minus 7, you factor out the negative, you're actually going to get that negative x plus 7, because if you put that negative inside again by foiling, you get the same answer. So that's true. That statement is true. We rearrange it. And now, why do we rearrange? Because if you rearrange, you note that negative x plus 7 is the exact same thing as saying 7 minus x. So what do we note now? Top and bottom both have 7 minus x. So that just allows us to kind of cancel that out pretty neatly, pretty sexy, pretty beautiful. And so how is that going to look? Well, the final answer then is going to be canceling out the top and the bottom, that 7 minus x, would be left with a, well, let me just show real fast how that will look, the cancellation, because we have that denominator right there, and the numerator right here is 7 minus x, and the 7 plus x. We just cancel that out right there, and we're going to be left with that negative 7 plus x over x minus 2. And you can just put that negative inside if you feel like it. Honestly, I think this is fine. Some teachers might want you to do that, but I don't really care. Now, these problems are a little simpler, but I just want to hammer some points home. So you note that here we can factor out a 2 in the top, this 2x, because both of them have x's and both of them have 2 in there. So you note that if we multiply that back in, we're going to get the same answer. So that's kind of the way you know if you can factor something out. Same goes for the bottom. We take out that 4. We're going to get x plus 3 because, again, 4 times 3 is 12. That's the beauty of factoring, because now you just cancel those out, those two terms, and now we get 2 over 4, which is the same as 1 over 2. And that times x. The x doesn't cancel. So yeah, that's our final answer. Now the next problem is similar to the one that we did before, where we realized that they're not quite the same, they're similar. So how do we deal with this? You factor a negative out again to change the order. We know that negative times negative 4 plus x is the exact same thing as x minus 4, or yeah, x minus 4. So once they're the same, you still have the negative outside. Those two terms cancel out, and you are left with a negative 1. So that's a simple way of dealing with those problems that kind of seem similar, but not quite. Now the next problem we're going to deal with is going to be none other than the polynomials again. And you note that that is definitely a difference of squares, right? We know that by now. And that's the same as saying x minus 3 times x plus 3, based on the little formula we learned before. And now we just have to think in the bottom, what times what gives you negative 7, yet when added gives you 5 once more. You should be getting pretty good at this ones by now. And yeah, I mean, the final answer for that should just be x plus 3 and x plus 2. You can slow down and do the math there, but those two cancel out, and you're left with x minus 3 over x plus 2. Boom, easy peasy. Now in this problem, I want to go over some of the exponent rules. So these are really simple exponent rules, but whenever you're having the same base divided by each other, all you're going to do is subtract the exponent. So in this case, 7 minus 4, 3. And in the other case, 5 minus 2 is the same as saying 3. So x to the power 3, y to the power 3. Because they're the same bases. Now note with the E, I'm dyslexic, note that here is actually the rule, where like you just subtract. But if you have the base being the bottom being heavy, is the same as saying 2 minus 5, which is negative 3. And that's the same, whenever you have a negative, it's the same as just putting it in the denominator. So that's 1 over y to the power 3. I just thought that's important for you to know. Now, what do we know about the 35 and the 21? Well, those are actually both the same multiple. There's multiples of 7. So 7 times 5 is 35, and 7 times 3 is 21. So we just cancel all those 7s, and we'll have 5 over 3, and that's our final answer. So boom, pretty easy. Now the next question we're going to deal with is 30 over 45, which again, same idea. You got that 6 times 5 is 30, and you got that 9 times 5 is 45. So we're just going to cancel those 5's out, and we're left with 6 over 9. And then the x to the power of 6, again, minus 3, is the same as saying, in this case, x to the power of 3, right? So they're pretty straightforward. And we're left with 6 over 9 times x to the power of 3, which simplifies to 2 over 3, right? So we're just going to get, here we're going to get a 2 over 3 times x to the power of 3. And that's our final answer. Pretty straightforward. So far we've only dealt with quadratics, but what when it's x to the power of 4, when our highest power is above 2? Well, substitution comes in. So, don't be scared. All you have to do is set that u equal to x squared, because now we note that we're able to turn it back to our regular quadratic, just in terms of u. So instead of having that x to the power of 4, we're going to have y squared, because we know that 2 squared is 4. So that allows us to do that. We're going to get y squared plus 10 times u, because again, u is equal to x squared, plus 9. And now what we have to think is, what times what gives us 9, yet when added, it's going to give us that 10. And the answer is 1 and 9, right? Because when you get 9 plus 1 is 10, and when you multiply them, that gives you 9. So yeah, that's pretty straightforward. Now we substitute back our u's, as we did before, and ta-da, there's your answer. So don't get scared whenever you see high power, just realize how you can substitute something in to make it work. Now the problem here is that we no longer have a difference of squares. You note that x squared plus 9 is not the same as x squared minus 9. So how are we going to deal with it? The answer is imaginary numbers, and I'm not going to go over the proof right now. I can if you just write proof in the comments and I'll go over it. But essentially what we're going to do is just treat it as x plus b times I times x minus b times I. So it's the same as difference of squares, just multiply it by I in the end. Now remember that x squared plus 1 is also a perfect square, because 1 is a perfect square. If you root it, it's also 1. So watch out with that whenever you have x squared minus 1 or x squared plus 1. And now I'm just going to do the same for the x squared plus 9 on the other side. And ta-da. This is our final answer. Now I'm going to go over the things you should memorize. Honestly, this is pretty straightforward. I like memorize it. I recommend you memorizing it. You can work your way through logically, but that's going to take too much time if you're in a test or anything, any circumstance. And here are essentially the formulas that I like to memorize. But yeah, take your time, slow down, just memorize them. And guys, I'm going to go over more videos. Just comment stuff you want to look over. I'm interested in everything related to science and STEM, honestly. So I'll go over any single concept you guys put. And I'm going to go over some stuff I learned in college too, which I think is pretty interesting. Again, guys, don't get worried. Like, I can give you any advice if you guys want in college, what I do with my life, what I plan on doing in my life. I can make a video about myself. I'm getting into this new YouTube channel, and I just want to, I don't know, get to know you guys, get to know my viewers. Please write down what you guys thought of the video, how I can improve it, and every single comment means a shit ton for me. Sorry for the bad language. But yeah, I hope to see you guys in future videos too, and I am very interested in every single subject related to math. So if you want to see another subject, just tell me. Also proves I'm interested in those too. So yeah, without further ado, this is kind of just an introduction to algebra. Guys, remember that algebra is the building block of everything. Calculus and all those problems in the future, honestly, are just built upon them. So if you have strong foundations, you should be fine in math. And yeah, thank you guys so much for watching my video, and I hope to see you guys in the future. See you later.